Okay, here's an example. You are preparing breakfast and slide a plate on the countertop. Unfortunately, you slide it too fast and it flies off the end of the countertop. If the countertop is 1.05, oh, I can't put a space there, meters above the floor and it leaves the top at 0.74 meters per second, how long does it take to fall and how far from the end of the counter did it land? So you can imagine that this is going to follow projectile motion. You have your countertop, it's nice and straight, the plate goes off, and it's going to hit the ground. So we have to draw a motion diagram. So let's say that this is the edge of the countertop. What we're going to have is we're going to have some vertical motion, some velocity in this direction. Okay, and then in this direction, we are going to have a constant velocity and we have no acceleration. Okay. Meanwhile, in the y direction, we are going to have an increasing velocity. And the reason it's increasing in velocity in the y direction is because we have acceleration in the y direction. And we know that that acceleration in the y direction is going to be 9.81 meters per second squared. Okay, and in fact, we actually know it's negative to show that that is the direction. So let's write some of the things that we know. So some of the things that we know is we know the original position in the x direction and the original position in the y direction is at 0 meters. We know that our velocity in the x direction initially, that's what that means, in the x direction initially, that initial velocity is 0.74 meters per second. Okay. We know initially in our y direction, there is no velocity. Originally, it's sliding only vertically, it has none. We know that my acceleration in the x direction is 0, and we might know that my acceleration in the y direction is negative 9.81 meters per second squared. I know my final position, it's 1.05 meters. And I'm going to put a negative to show that it's, if we started at 0, we've gone to negative 1.05. We could have also done something here. We could have started this at 1 and this at 0. Either way, it would come to the same understanding. Okay? Now we need to find an equation that we can use to get what we want to find out. What we want to know is we want to know x final. Unknown is our final expedition. We want to know, and we also want to know time. So how long does it take and how far from the end of the counter? Well, how far is the x direction? So we want x final. Okay, looking around for a formula. Let's first of all see if we can solve for time. Well, it looks like we have a position or a displacement. It looks like we have an initial and a final in the y direction. We also have an acceleration in the y position. So we're going to use the formula displacement equals 1/2 AT squared. Sorry, I had that formula wrong. It was displacement equals v initial time plus 1/2 AT squared. So, a couple things. We're doing this all in the y direction. So we're saying the final y is equal to the initial speed in the y direction times the time plus 1/2 the acceleration in the y direction, t squared. Okay, couple things we know. Y final is negative 1.05. That was right here. My initial velocity was 0. So 0 times anything is just 0. We can get rid of that. We have 1/2 acceleration in the y direction. It's right here. Is negative 9.81 meters per second squared. And we don't know what time is, time squared. So we are going to solve for time squared. We're going to get that time all by itself. So we're going to have to multiply both sides by 2 to get rid of this. So 2 times negative 1.05 meters. And we're going to have to divide by negative 9.81 meters per second squared. That will give us time squared. To get time by itself, we are going to square root both sides. Okay, just rewriting in the opposite order, we would get time is equal to, and we're going to have to do this calculation. 2 times negative 1.05 divided by negative 9.81. When I got this all done, I did all of my work. I see that time, or my sig figs, is 2. I got 0.46 seconds. Okay, so make sure you try your calculator that you can get that same value. There is my time. Okay, now we need to find out when it hit the floor. So in other words, what we want, I'm just going to pause for a second. Okay, so we want displacement is equal to speed times time. In the x direction, so we're saying this is the x final position. We want the velocity in the x direction times the time, which we just found was 0.46 seconds. From our problem, we said velocity in the x direction was 0.74 meters per second. That's what it says in the question. It says that it leaves at 0.74 meters per second. So we're going to keep that. 0.74 meters per second. So x final equals 0.74 meters per second times 0.46 seconds. Multiplying that out, and we are going to get 0.34 meters with significant figures. Meters per second times second, we're just left with meters. Okay, so let's make sure the units are correct. Meters, yep. Seconds. I didn't double check that this one was seconds. Let's look at this. We have meters divided by meters per second squared. Meters divided by meters per second squared. Okay, well, meters divided by meters. Actually, we should multiply this by the reciprocal times second squared over meters. Whenever you divide by a fraction, it's the same as multiplying by the reciprocal. Meters cancel out. We're left with second squared, but we have square rooted that, so we're left with just seconds. And does that make sense? When you throw a plate, that it would take less than a second to hit the floor, a meter? Yeah, that makes sense. And does it make sense that it would go about 1/3 of a meter? Yes, that also makes sense. Okay, so the principle here is that the motion in the x direction is completely independent from the motion in the y direction. With projectile motion, we have no acceleration, we have constant velocity in the x, and then we have acceleration due to gravity here. We looked at displacement slightly different. We said in the x direction, and then we also had to do it in the y direction.